So we've clicked on the map view. You have to select a region to start with. So in this case, if you come here and there's no data on the screen, you should come in and immediately pick your region. So I'm picking the CDTC MPO region, and so you see the boundary for it, and it immediately loads the LOTTR as the default right now, and it'll be defaulting to 2021 data. What the macro view currently does is it shows the performance measures at the year level. I've selected 2019 because, as we all know, 2019 was the last quote unquote normal year of network behavior, but 2020 behaves incredibly differently. So I'm going to do this work today on 2019. What I'm going to be showing you today is I'm going to export some data. I'm going to export it as a CSV, and then I'm going to move it into Excel, do a little bit of work with it to clean it up, and then rank things. So the first thing we want to do is we want to set the year. So when we're working in the interface over here, these pieces, the network, the geography, and the year, set your download. So the year we're downloading is 2019. The network is the TMC, and the geography, again, is the CDTC MPO. So the next thing to note here is in the map view, we can turn on bottlenecks just to get a quick view of what's going on in your region. It's going to highlight the top 30 LOTTR rankings, right? And if we change this performance measure to the total excessive delay, or to the any other number, TTI or PTI, it'll change your top 30, and you'll be able to see all these. But the nice thing about exporting is that we can look at all of those top 30 side by side and see how a segment behaves against with each of these performance measures. So I'm going to move into the export here, the open the data downloader, and I've already selected the pieces that I want to look at here. So the way to select values here is on the right side. For instance, we've selected a couple of TED measures, which is the total excessive delay measures, and you'll note that on once you've selected the measure, you have these additional filters that you can choose from. So you can use free flow speed. If you select this means that you're using free flow as your threshold as opposed to the speed limit as your threshold. The thought here is that for signalized arterials, the free flow speed is going to potentially be lower at your signalized segments, and so the threshold speed will be lower, so you'll be gathering less excessive delay on those segments, and so that's, and additionally this will show probably higher speeds on highways than the speed limit as well. So that would actually gather a little bit more excessive delay on the highways by setting the threshold speed higher. So we are going to use the free flow here, just because that's the way we've done it here. Again, this is a choice you can make on your own. There's value to both, and the way that the federal highways does their PM3 obviously here is they use the speed limits. So if you prefer to be in alignment with that, then don't select free flow. So the second thing here is using RIS AADT. I'm going to recommend this for everybody. The other AADT that's in here is provided by HPMS, and it's in the NPMRDS shapefile that comes from federal highways through the RIDIS system, right? That AADT will not show up on the expanded INRIX data set. So the expanded INRIX data set doesn't have the AADT on it. So there's a number of segments that just don't have associated AADT. You'll see this in the spreadsheet when I download it, because just doesn't have that AADT from federal highways. So that's just a note to make. the RIS AADT then allows you, if we're using RIS AADT, you can get total excessive delay on the expanded network. So that's an important piece to remember. The other thing is that, as you see here, I've set myself up with two different versions of the TED. One it says per mile at the end, and the other doesn't. I think this has been mentioned multiple times in this forum, but the per mile is a normalization so all the TMCs are not equal lengths, and length of a TMC has an effect on the amount of excessive delay that you're picking up. A longer TMC means that it takes longer to traverse the segment, and time is one of the functions of excessive delay. So a longer segment will always pick up more time due to the length, right? And so what normalizing to a mile does is it gives us the ability to compare segments as apples to apples. It makes every segment a mile. And so if a segment is actually below a mile, you're increasing the amount of excessive delay. If it's above a mile, you're reducing the amount of excessive delay. But this gives us the ability to rank segments as though they're all a mile, right? But I'm downloading both because you're not going to want to report on the per mile because it's not an accurate summary of the excessive delay. So we're going to do, we're going to add both per mile and not per mile. And then this last one is whether or not you want to look at this as vehicle hours or person hours. This tool uses a multiplier that Federal Highways provides to determine person hours, which is just a constant multiplier on vehicle hours. So so then after you've selected all of this stuff, you hit add measure here. So now you can select your measure and you've added it to your performance measure list up here. I'm going to remove that because I don't necessarily need that one. I've also added in here, I've added LOTTR, I've added TTI, I've added free flow speed, miles per hour, just as a check on my, so showing free flow per mile is one of my checks on the TED measure. I've also got percent of epochs reporting, and this is going to be important because we're still trying to hone in on exactly what the percent of epochs reporting makes sense to, as a best practice for a threshold for whether or not you should include a segment in your analysis. Today, I'm going to do a very brute force version of it. I'm only going to do total percent epochs, and I'm going to do 30% of epochs reporting. But through the work that we did with Mid-Hudson Valley and Syracuse a couple years ago, I think ended up recommending 30% of peak speed on a minimum peak. For today's purposes, we're just going to do percent of epochs reporting total for the route. So it's a simple little maneuver. Then we can add metadata variables as well. You have to see this whole list over here. We're adding length of segment, miles, which again is important just to understand our per mile TED. We're pulling in the AADT. We also are going to pull down the associated road name, the alternative road name, and the associated street name, first name. These three together really do, and the direction as well. All of these four pieces help. They each show a little bit different information, so it helps to give some amount of context to where each segment is, because a TMC is just a string of numbers and letters that doesn't make much sense. So these are the four things that we've identified as having as a collection. They have enough context, and then we're pulling down the functional class as well. So that's our download, and we're just gonna pull this down. It takes a couple seconds. It's pulling a lot of data. See it over here, your loading mechanism. And we're gonna open this up here. And the first thing we're going to do is we're going to start moving these around. And this is something that maybe makes sense as well inside of the software, is to be able to order this spreadsheet download. Right now it comes out with the performance measures first and the metadata second. For what I'd like to do, I would prefer to move all of this around a little bit. So moving all of my measures we're going to cut them and move them over to the outside here. Insert cut cells. I'm going to move percent bins reporting to the far outside. I'm going to move the name of the route. Let's see, which one is, here's the first name. We're going to cut this, put this over here. Alternate name, put that over here. The route number. So just organizing this stuff here. Cut that, put that in here. And then the F system, let's move that over here too. So now that I have that, I'm going to add one more over here, and this is going to be my my threshold for data. So the threshold is where we're going to cut data that's below a certain percent of reporting. So this is percent bins here. This is showing you how many epochs are reporting, and so this one has 5%, where this one down here has 95% reporting. So what we're going to do is we're going to create a table here where I am going to say we're going to select all, right? By Control A, it does a select all for me. So I have now all of these. There's some how many thousands of yeah, close to 3,000 segments here that were downloaded, and I'm going to create a table, and we're going to say it has headers, and now we can start creating a couple of different calculations here. So the first one is going to be a min. So this one equals min. We're going to say it's this one, and so what we're going to say is the column O is greater than 0.3. So this gives us a true false, and if it's not above 30%, it has a false next to it. So the next thing I'm going to do is remove the trues from this list, right? So now this is all false, and we have, you know, a long list of ones that don't meet the 30% threshold. Now, if we did 30% threshold for peaks, there would be a much higher number, because this is saying 30% of total epochs, right? That's going to cancel out a whole bunch of these routes. But again, this is a brute force version of it. When you download percent bins reporting, you can say, I want to do peak, I want to do AM peak, PM peak. You can do multiples of these, and then do this threshold on multiple columns. So for the purposes of today, we're doing a very brute force version of it. And I'm going to remove all of these from my spreadsheet. And at this point now, it looks like we have no data. We're going to turn this on and say this is now true. And so this is the selection of above 30% reporting. It's going to be about 560 segments in the region. Okay, so that's the first major cleanup step. The next stuff I want to do here is I'm going to take TED per mile. I'm going to cut this one and move it over here. What I'm going to do is I'm going to rank these things. So just a simple maneuver here. Bring in a new column next to each of these performance measures, and we're going to rank them all and just look at how they compare in terms of rank. So this is going to be TED rank. This is going to be LOTTR rank, and this is going to be TTI rank. And we're just going to say equals rank, and we then give ourselves a parens. So just selecting the column we want to do, comma, L to L, so the whole column, L to L, comma, 0 is going to put it in an ascending order, and 1 is going to put it in a descending order. So this just threw our ranks together. If I take this one and I put this in ascent from largest to smallest, you'll see that we have our TED rank. Again, if I just turn this 0 to a 1, it'll flip the whole thing around. So we're gonna stick with that 0, and we're gonna make that for each of these. So equals rank, and it's this, comma, n to n, oops, comma 0. And equals rank this d 0, boom. So you can see already that, like, so one thing to note here is that what we're looking at with LOTTR and TTI, the reason we brought those in, this is our first sort of pass at doing some of these rankings. And our understanding of TTI versus LOTTR is that when it comes to TTI, what you're comparing, so that the travel time index is comparing the free flow speed and the average peak speed for the worst peak. So for instance, and if we flip that over to travel time, it's easier to understand. If it normally takes, you know, a minute to traverse a segment during free flow travel conditions, and during peak travel conditions, it on average it takes 2 minutes. That's going to be a 2.0. So it takes twice as long to traverse the segment during peak conditions, during your worst peak conditions. That's what a TTI, so a 2.6, this would be a 2.6 longer, right? Or this one here is 3 minutes, and you can see that one's ranked number 1. So a 3-minute differential is quite a big difference, right? So that's TTI. LOTTR is pointing out something different, and that's saying within the peak there's a wide distribution of travel times. So even though the average travel time for peak might be, you know, let's say it's, in this case, it's 3 minutes ish. With LOTTR, what's showing here is 80th over 50th during the peak. So it's saying, you know, the 80th percentile travel speed or travel time is like it's pulling that average out in a way, right? So it's like the spread of what happens, the variety of bins of travel time is just wider. There's a lot more, and I can kind of show you a visualization of this, right? So as you see here, this is you know, a normal, you know, distribution ish of speeds, right? This is I believe this, right, this is one of the worst performing LOTTR segments in the region, right? So select smallest to largest. Let's do rank, actually, smallest to largest. So this is going to be either 582 or 584, and where does it tell me what it is? It's up here, 852. Right? That's how I said it, 852, right? So this is the worst performing LOTTR segment. You can see here there's this swath of like travel times that you know, the speeds here, it's in speeds on this visualization, but these are really, really long travel times over here. And so the 80th to the 50th is going to be a very, you know, big difference. And so that's how you're getting your LOTTR. This one also, I think, has a high TTI as well. It's ranked 4th in terms of TTI. So again, that's showing your peak versus your peak versus your off peak, right? And so you're seeing here all of that behavior that occurs here. It's all peak related, and so there's a clear peak to off peak. This is a really good example of a TTI, a high TTI score. So we've ranked these scores, or these three different things, and so the next thing I want to do is I want to show about normalizing too, because we're going to make a composite score here just to try to see what happens when we combine LOTTR, TTI, and TED, right? Because right now the list, the rankings are showing up very differently, right? If I rank LOTTR, we've got a couple of interesting, you know, the excessive delay routes are not all the top excessive delay routes. If I change this to look at the TTI, smallest to largest, we're starting to see, yeah, there's a bunch of the excessive delay areas up here, but you know, it doesn't necessarily always correlate with LOTTR or TED. So you know, we were just playing around with this and started to see if we could make a composite score, and if that would pick out some of the worst segments in the region, if it would make sense. And so this is you know, the first step of doing a composite score is to try to bring each of these measures into some comparable size, right? So over here, we're going to do a TED normalization. So insert, and we're going to put this in here like this, and this is, I just got to change these to M. Oops. And we need to change this to the right column as well, which is this column. So that should give us a normalization. This, and I'll show you, just we're going to do a quick check on what this is doing, right? So this is TED norm, and the rankings here. So if I take this and I rank this, what it's really doing is it's saying the highest rank, or sorry, the highest amount of TED is now a 5. The lowest amount of TED is now a 1. So I've just made a scale of 1 to 5, where the highest number is a 5, and at the bottom of the list, the lowest TED numbers are now 1s, right? So this isn't going to change the rank at all. It's really just taking it's sort of compressing the TED into a 1 to 5 score. You can see as it's just exactly ascending all the way up to the 5. That's our top ranked one, right? So that is what we're going to do to all of these columns. We're going to insert another one here. We're going to say LOTTR norm and steal this equation again. And this one is going to be based on O to O. So we are now going to look at this. Beautiful. And we're going to do the same thing over here with TTI. And this one's going to be R. We're going to insert two new columns for our composite. This is going to be composite score, and this is going to be comp rank. And we're going to just do a simple composite where we add these up. So we're going to say equals TTI plus LOTTR plus TED. And then we're going to rank those equals rank this, comma, U to U, comma 0. And get our rank in here. Now, we did this quickly once. We looked at this version of it, and it ended up being really heavily weighted towards reliability. So like the issue with a composite rank that's just adding these up is that it takes it takes TED, which I think most of us probably agree that the TED, the excessive delay, is probably the most important of these three. I could be wrong about that, but in our first pass at looking at the composite score, when we just did a simple additive composite, it didn't necessarily bring to the top of the list some of the routes that we expected. It brought a couple more of these like signalized arterials, partially because LOTTR and TTI end up having like weighting it in a direction there. So one thing we can do in our composite score, and this is the thing that our team is really trying to figure out, we're doing a couple tests on this, is how do we weight it? And so in weighting it, we're going to just say, we're going to take our score is, so when all of these are added up, it equals 1, right? I'm going to say that TTI is 25% of the final score. I'm going to make LOTTR 25% of the final score, and I'm going to make TED 50% of the final score. And I'm going to get a different ranking system here. And so this is now smallest to largest. And when we come across to our routes, this starts to really look like what you'd expect. We've got, in the capital region, we got the Collar City Bridge. We have Wolf Road and I-87. We have the Adirondack Northway and Route 146 West. It's an interesting one. We'll take a look at. We have this one that I mentioned earlier, the 852. It's, even though it's ranked TED, it's ranked 57th in the TED. It's ranked so high in the TTI and the LOTTR that it ends up getting a high ranking. And this is a related one down here. This is it's very related to this top one, but 854. And I know this already because I've looked for this route, but it is the exit ramp from Route 7 extension to I-87. And one of the things that's interesting about this route, if we go into our again, this is the one that we're looking at here. When we go into this tool, we can take a closer look at, a lot of these are all of our rankings for LOTTR, and a lot of them are associated with that ramp. And we also have this nifty new Transcom incidence layer that we can add in here. It takes a second to load in, but we can see here that if we just select accidents, there's a real cluster of incidents over here in this section of the world, more so than pretty much any other places. You see there's some incidents, clusters of incidents in these areas, but this really does sort of point to identifying the areas where there's a lot of incidents. So we're still at the point where making this composite score and looking at it inside of these, inside of these tools, there's no way for me right now to say, okay, I've got my composite scores, put those on the map and let me see how those relate to the other scores. It's something that makes a ton of sense in the future to be able to try to do here. But for the time being, we're coming in, looking at different scores, different high scoring composite, high composite scoring segments, and taking a look at the map, taking a look at incidents, and trying our hand at figuring out, how well this composite works. As it stands, this sort of gives you a way of saying, okay, I want to look at 3 scores simultaneously and, give them a little bit of weight and see if what I come out with makes sense to me. So my rankings over here of that composite score, and just to look at what this looks like in like a scatter plot, for instance. This is basically what, so this is your composite score, right? 1 to 5. And across each of these different colored things, so we have our rescaled TED, we've got our rescaled TTI is going to be green, so the TED is blue, the TTI is green, and then the red is the LOTTR. And you can see that, like, so just to point out, so this would be a single segment across the top. This is the highest scoring segment. It has 2.0 LOTTR. It has a 4.0 TTI, and it has a 5.0 TED. So this is the highest scoring TED. It's also the highest scoring route. The next highest scoring route is has the highest TTI, has a very high TED, and has a fairly decently high LOTTR. So, but what this is really pointing out is that by using multiple measures inside of a composite, we're sort of picking out like these collection of outliers here. And so at some point it'd be neat to be able to see which of this box up here are ones that are behaving odd in multiple measures, or at least in one measure, and so it sort of brings this list to the rest of these are behaving in a very correlated way, right? These are all the ones that start to spill out in a way it's obvious that those are the segments that are the ones in the region that are probably the ones that we want to be focusing our effort on. Now, if I were just looking at the LOTTR, for instance, I might not be picking up on the highest scoring route here for my composite, nor would I probably be finding this second highest scoring route. So, because this one over here is the highest scoring LOTTR, and it's got a very low TED. So this is a visualization that we don't have inside of the tool right now. It might make sense to bring it in at some point, but I've done this in SPSS to sort of just take a look at what that distribution looks like.